Hello, welcome to the Munro Live podcast. I'm Julian Yates. I'm joined by Antonio Dineno and our special guest, Jordan from The Limiting Factor. Jordan, thank you so much for being here.
Thanks for having me.
So I guess we'll start off talk a little bit about you, your channel, your process, how you select your videos, how you go about doing your research, things like that. We're personally very curious to know.
It's chaotic is probably the best way to put it. I don't even know where to start because as the channel has progressed, the way that I choose videos and the way that I develop them has changed as well. I'm constantly working to streamline the process. I don't know if there's much there that I can eke out now, but I'm probably about, in terms of the process of making the video, I'm probably about twice as efficient as I was when I first started the channel. However, it still takes me just as long to produce the videos because I find that I use that extra time to improve the quality of the videos.
Sure.
But from the very beginning, it's been a matter of trying to build a base of knowledge. Sometimes I do videos that they're not really clickbaity. There's not a lot of people that watch them. There's not a lot of people interested in them. I might get 20,000 views on something, but I need to learn that information in order to make videos in the future. So there's a topic that I want to cover, and it's like, well, what's the first thing that I need to understand about that topic to, work towards the goal of providing a broader understanding.
Mm-hmm. Right. So one of the best ways to learn something is to teach it to someone else.
Yeah, and one of the best ways to find out you're an idiot is to show something to 20,000 people and have them tell you you're an idiot.
No, we know.
Yeah, no crime greater on the internet than being wrong on the internet. You can not file your taxes. You can commit an offense against the corporate system. But
yeah,
being wrong on the internet, there's no forgiveness.
Yeah, and it's I really appreciate the people who give good, well-considered feedback. That is just pure gold. So, yeah, I guess there's a saying that if you want to learn from somebody who's never made a mistake, you're never going to learn anything. Mm-hmm. So I appreciate the people who see it in that light and cut me some slack and try to educate me. Mm-hmm. Because there are people that assume that you're kind of a huckster or something like that, trying to just get as many clicks as possible. But it's because there are a lot of people out there just doing clickbait content. Mm-hmm. And yeah, so.
And your material is pretty technical. So you have an engineering or chemistry or science background?
No, not at all. I just, I'm curious.
So you're not a didact?
Yeah. The way the channel started is, one of the reasons I did my first videos is because I was frustrated with the quality of information out there on batteries. I'm like, I don't know anything about batteries. I know very little, but I know that is wrong. So I just saw a lot of YouTube channels reporting on batteries, and I was like, that can't be right. So I was like, all right, well, I'm going to try to progress the conversation a little bit. I did that. I feel like I progressed the conversation a bit. People gave me feedback and said, all right, this is where you're wrong here, here, and here. I took that into consideration, did better the next video, and it's just kind of this constant feedback loop.
Sure.
And then what happened, and this was the unexpected and exciting part of the channel for me at the beginning, was that as the quality of the information improved, I caught the attention of people who were experts in the field, and then they started giving me feedback. So you kind of work your way up the totem pole from people who are, they tinker around their garage or something like that, and then within a few months, you're talking to some of the biggest experts in the world on batteries. So right. I was 6 months into the channel, and then I was interviewing Shirley Mung from UC San Diego. Mm-hmm. And she's been mentored by Stan Whittingham and John Goodenough, some of the fathers of current lithium ion batteries. Yeah.
I mean, it's one of those isolated industries where it's not very often you hear feedback from a community or get acknowledgement. So seeing someone else cover their materials oh, this is nice.
Yeah. There's an appreciation there. So I feel like I was embraced by not just the Tesla community, but also the research community as well. Mm-hmm. So I don't know if that answers your question about my process, how I select videos. Yeah, it's organic. And it's all I have a board of videos that I'm working on. And I constantly have to scramble and mix that up because there's the things that I want to cover, things I want to learn about. And then there's also Tesla throwing sticks in my wheel every time they do something new or different. It's like, oh, like 80% of the time when I'm making a video, I'll be a third of the way through it, 2/3 of the way through it, or I may have just released it just for my Patreons. And then Tesla changes something, so I have to go redo that part of my video.
Yeah.
So probably 20% of the work I put into the channel is redoing crap because Tesla changed something on me or a new piece of information came out. So
we deal with that quite a bit too, because even just, within a single model year, we've discussed this with various clients who've been in the building. At one point we had a customer here and they wanted to take a look at the a couple different EVs, including the Model Ys. So we had both the 2020 Model Y with the 2170 form factor cells, as well as the 4680 pack Model Y. And we had them out next to each other, and they asked us, well, are they only producing the 4680 pack, or are they doing both? And then as we discussed it, they kind of came to the realization, like, there's a same model year vehicle, same model, and it is out there effectively with two entirely different architectures. That is just completely wild. So, us trying to play catch up in that way too, tearing something down, costing it out. And then, as we're in the middle of that, we see, like, I know Tesla just had their hairpin EDM, unit come out. And so that's something that's a lot different than what we've seen. And it's hard to keep up with them for sure.
Yeah. And they'll have multiple iterations going, there's different iterations of the same vehicle, and then B, there's start and stop certain things. Like the 46A version, as I understand it, they're producing it for a few months and then they stopped and now it's back online again.
Right. And the 4680 is a nice little segue into some of the deeper stuff we can talk about because we both dissected the cells, we've done research on them, and we've discussed our findings with each other.
Mm-hmm.
So that's like one of the other things, like we've been conversing for a little while regarding some of the technologies out there, some of the things we're seeing, and it's good to have a fact checker in the room.
Mm-hmm. Yeah.
Vice versa. Because, there's so much, a lot of what we have to do with Tesla, because so much of what they do is trade secret or in development. It's behind closed doors. So you want to do a sanity check. It's like, am I going off the deep end here? Am I assuming too much? What's the most logical approach to this? Tell me where I'm wrong.
Right.
And there's like a few different groups of people that I interact with to basically do sense checks. So it provides a lot of value for me. I don't think people realize how much communication is going on behind the videos and behind what you see in the Tesla community. A lot of us are talking to each other, interacting, checking things. So,
Yeah. So, Antonio, you mentioned the 4680 pack. Did you want to go into a little bit? And I guess maybe, Jordan, for you, obviously you saw the cell portion of that. You had it torn down and analyzed. Was there anything that you were curious about, in terms of the pack level, or anything that maybe was outside of just the cell analysis you had done? Are there any lingering questions you may have for us?
Yeah. Because there's I speculated quite a bit in my videos about Tesla's ability, because this is, for me, it's a very early pack. To me, this thing was just beyond prototype. It felt like it was, it was fully operational, fully commercialized. However, it was definitely a version like 0.9 or 1.0 that they put onto the market in terms of the battery cell. And my assumption is for the Cybertruck that what they're going to do is they're going to strip a lot of the weight out of the battery cell itself, improve the engineering of the cell. Everybody's focused on silicon, things like that. I don't think Tesla's going to start adding silicon to the battery cell until they have their manufacturing process really dialed in and have a somewhat final version of the cell. So strip weight out of the cell, but so I have strong reason to believe that there's going to be quite a bit of weight pulled out of that next version of the cell. I can't say more. But in terms of the pack, I'm curious what you guys think can be done or how much they can improve the pack level energy density of the pack.
Sure.
Battery cell aside.
Well, we did see, I just double checked some of your videos before you came on, and then you rated the pack as a D. And yeah, I'm in agreement because we did see a lot of the step changes that are necessary to get to the future technologies within the pack. So the carbon nanotubes in the anode are definitely a step change towards getting silicon in the anode. So many other things. It's like, yes, they're more structural, but that might just be a placeholder so that it passes all the tests for vibration and dampening. But yes, the pack is, with Tesla, everything is a work in progress. There's no such thing as a finished product. There's no model year end. This is what we're going to publish and this is what we're going to produce. It's always changing.
So it's kind of like, at least my perspective, it's the first time you might, at home, you might design and build like a step stool or something like that, and you use 2x4s and put like twice as many screws in it as you need to.
Right.
And then the next version of it, you go, okay, I can I can shave that down to 2x3s or something like that, put half as many screws in.
Exactly.
And so I think they can, I don't know, I'm hoping just with the pack itself, not the cells, that they can maybe improve it by 10%, and then just pulling that figure out of the air.
Right. Yeah, I know. Yeah, so speaking, Antonio's got more of a background in the chemistry of it, and I'm more, mechanical oriented. And so, just taking a look at the pack structure itself, without even making a change to the cell chemistry itself, improving your volumetric or gravimetric density at the cell level. We were talking a little bit briefly before about that high density foam out to the outboard sides of the pack. There's about 100 millimeters on either side. So in theory, depending on, that may have just been overcorrecting, seeing how well it went, and then they can dial that back later. So in theory, you could cut that distance in half and add an extra row of cells to either side. You'd have to do some reconfigurations in terms of your current collectors, your S&P configuration for the cells. However, in terms of packaging an additional, I think that would, if we're going by the bandolier number, you could package up to maybe another 69 cells into the pack. There are about 69 cells per bandolier, so there is an option, just physical space-wise, to just put more in there.
There's room to make it longer, there's room to make it wider. But yes, like other competitive models where you're seeing, they have batteries all the way to the edge.
Yes, even other Tesla packs. Yeah, that's definitely the most generous I believe they've been with side sill, side impact considerations. And it could, be that they, extra screws more than you need, but maybe you just want to, exactly.
And did you ever get a figure on the density of the foam itself? Because what I did is I took a syringe at home and I dropped a little piece in.
Yeah, that's yep.
And it came to me as like 0.6, something like that. But there was definitely a big margin for error there.
I want to say that we did a very similar test internally, and we were getting somewhere around 0.5 grams per
0.51, yes.
Yeah, so it was more or less, pretty on par with yours. But it was kind of a painstaking process because you can only get such a large chunk out of it, and it's just even getting the foam out to begin with was a challenge. But
and one thing I'm wondering that just came to me was that it's like an epoxy foam, or is epoxy, is that what it is? Urethane foam. Can they increase the ratio of air or in that to lower the density of the foam?
Absolutely.
Okay. All right.
They can do other things as well.
Well, don't tease me.
There's fillers. They could do like a fiber. It could be glass. It could be cellulose.
Oh, yeah.
And it would increase the rigidity while taking out some mass.
Well, what was interesting, too, is taking a look inside of the thing, because there were pultruded fiber boards inside the pack that whereas maybe if there was a longitudinal, so like in the original Model Y, you had the extruded longitudinal members inside the pack to separate the modules. In the 4680 pack, there were pultruded fiber boards that effectively just floated in the epoxy and just sat between the cell arrays, just more of a electrical and thermal isolation measure. But looking along the side of that, you could actually see during the teardown where the foam itself was so viscous, you could see it dripping down the sides, and it didn't fully impregnate the entire void space inside the pack. So there were still some, I think we estimated like maybe they had 95% of the void space actually filled with the foam. That wasn't able to actually get to all of the spaces anyway, but I think, possibly aerating it or having some fillers there, but maybe increasing the space that it's getting to.
Adding something changes its properties. So maybe it flows less well and it doesn't fill those gaps as well if you add fiber adulterants to it.
What's pultruded?
It's almost, it's like and I could be wrong here just from what I remember about researching it, but it's effectively like a fiber reinforced composite that's almost like extrusion.
It is a brand name, right?
With the pultruded fiberboard, or
Yeah, Pultrusion is a brand name, I believe.
I'd have to double check that. I just know that's it could be. I assumed that it was the process that was used, but we can double check that.
It's like extruding a polymer.
Yeah.
Okay.
Yeah,
I
just
got
with
you.
fiber reinforcements, and even blasting it away with the dry ice. It's a lot like the carbon wrapping on the rotor. It was very fibrous. We were picking it out of our fingers for a couple days after we handled it without gloves.
Yes,
somewhat naively.
Memories.
Yeah,
That sounds like it was a blast pulling that thing apart.
it was quite literally with the ice blaster, but it was. Yeah, no, that I think. How long were we taking that thing apart for? It had to have been over 3 months.
Yes.
It took about 3.5 weeks just to get the lid off, and that was before we had the dry ice blaster. Then once we had the lid off in its entirety, about a month of dry ice blasting. We didn't have an air compressor that was large enough to run the machine longer than a couple seconds at a time, so we had to go rent basically a mobile construction site air compressor, hook that up to the dry ice blaster, start clearing away the potting, and then peeling up through the current collectors. And then to actually extract the cells, I meant to go grab one before we started, but we actually had to, because they're on the cooling bands, the serpentine bands, and they're glued there. So the only way we could actually extract them is we had to construct it. Basically, it was a 1-inch copper pipe with a, flange out to a 2-inch, which was more or less the OD of the 4680 cell. And we had to take a dead blow hammer, set this, what looked like a cocktail shaker, over the top of each cell and smack down on it until we could crack it off of the cooling channel to actually get it out. And we got, I think, 521 cells out that way.
I think we had over 600.
You're right. It was 600. And 621, because then the next module would have made it the full 828. Right. So, so it was a fairly arduous process, to say the least.
I can imagine, because I had one cell, and it's like hardtack candy coated to the outside of the cell, and I had to, shave it off with a chisel without piercing the cell can, just to get a little sample of it.
Yeah,
I probably shouldn't have been doing that, but I was curious. I burned a little bit.
We've done worse. Don't worry.
Yeah, it was quite because you had to get it to seat just right. Otherwise, you could very easily dent the top of the can, or we were pretty nervous. And then we were also, it was the middle of August, so it was nice and humid. And then we're, spraying this, frozen CO2. So we had all this condensate forming. So we had to have people dabbing off the batteries as we were blasting, so we didn't get too much condensate going. And, it was a little bit of a mess, but.
I mean, there was no established process for it. No one's done it before. We were figuring it out as we went.
Do you think the next one you'll be able to tear it down more quickly with what you've learned?
Yes, I think now that we know what to expect, very much so. In terms of changes that could be made, so say they reduce like that foam on the sides of the pack, there would be more overall potting there. But overall, I don't think that would impact the process very much. I don't know any improvements they would make, if it would make it more difficult to tear down than what we had done. Part of it was honestly just realizing, and I think somebody in a comment on one of our videos had actually suggested the dry ice blasting. So then part of it was in the middle of trying to get this done, in a time crunch. We had set a tentative, end date for this, not knowing exactly what it was going to take to get it apart. So we had to find a place that would let us rent a blaster like that day. Had to figure out how much that was going to cost. And then it's, they sell you the ice pellets by the, 500-pound box. And it's like, okay, well, how much are we going to actually use to get this thing apart? How many 500-pound boxes of ice do we need? So we learned pretty quickly that we didn't order enough. So we basically had, shipments almost every other day coming in with 2 or 3 of these boxes. You'd feed them into a hopper, and then it almost looked like a, Ghostbusters gun. We just, and it was slow. It took quite a lot of material, but.
Yeah, well, I remember you guys getting some flack because people thought the cells were too expensive. But I was like, no, I think you realize that there's this whole business around just having the expertise, the equipment, taking the risk, et cetera, of pulling that pack apart, safety, all these different factors. It's like, that's how much it costs to, pull a cell out of one of these. And pay for the teardown and stuff. So I thought it
Yeah.
was fair.
Yeah, no, it's just I mean, in terms of the man hours, it did end up being fairly. it was pretty fair as it worked.
Yeah,
out.
and on top of that, you didn't sell all the cells. You need
Mhm.
to keep some around for other purposes.
Right.
One thing I want to circle back on was that you mentioned carbon nanotubes.
Yes.
Because I know if I wouldn't touch on that, people are going to be like, "What carbon nanotubes?" Because I didn't come across carbon nanotubes in the battery cell. So I just want to get some clarification there, make sure we're on the same
That was
page.
the fibers that we saw in the anode, right?
Oh, the carbon fiber. Okay, so those fibers that we saw, like those spider silk-like filaments, that's like kind of like a Teflon. And what they do is they kind of mush it and run it through a jet mill, and then it fibrillizes and it turns into those threads.
Okay.
So it's not carbon nanotubes, but rather just Teflon that's been bubblegumized.
Teflon in the anode. I didn't think it would last there.
Oh, well, now we're going to get into deep technical stuff. It doesn't.
Oh,
My understanding is it doesn't. Like when Maxwell was running tests on those about 10 years ago, they were seeing first cycle losses of around 20% on those battery cells. So one of the things that, like, everybody thought that the anode was going to be the issue for Tesla, but that's what they started with. And it's the cathode that they're having issues with, more to do with the production process. But electrochemically, when it comes down to the deep science, the anode is the more difficult one to do. So I did a video like 4 months ago. I found some patents for Bosch. What Bosch did is they said, okay, we're going to have this fibrillizable binder that kind of turns into bubble gum. And what's going to happen is after you cycle that battery cell, that's going to break down. But what we're going to do is we're going to put an auxiliary binder, a secondary binder in there that's typically used on an anode. So you use the fibrillizable binder to form those nice sheets that get compressed onto the copper foil. And you put it in the battery cell. That first binder dissolves and breaks down, and then you have the other binder that actually holds things together when the battery cell is cycling.
Okay.
And I was like, well, Bosch has a patent for that. Is there any other way to do this? This is fascinating patent stuff, patent games. I found a patent for Tesla that said, oh, we're also going to use a secondary binder, but the reason we're putting in there is so it flows better when it goes into the machine. So it's like you get the benefit of having that secondary binder in there, but when you're playing these patent games, you can get away with things like that. Oh, I'm actually using it for something different. And they're probably getting some substantial benefit out of the flow, getting that material to flow into the dry battery electrode machine. But it's like people think that if you have a patent for something that you're good and nobody can touch you, but you really have to look at the wording of the patent and how broad the patent is. Right. So I think they were able to get around it. And yeah,
So I assumed it was single wall nanotubes because I went to the battery show and one of the presenters there had an image that was eerily similar to the ones that we took whenever we were doing the anode analysis. And they was like, oh yeah, wink, wink. This might be some of the stuff Tesla's using, and it's our single wall nanotube material.
Okay. Well, I found a lot of these early stage startups. They'll mention Tesla, wink, wink, but
Right.
and what they're trying to do is just kind of more. It's that halo effect. They want to be more closely associated with Tesla does, and maybe Tesla will do that. I've heard rumors to that effect that Tesla might be using other materials along with their silicon when they put it in there to actually hold things together. Because, it's a miracle that they even got the anode to work as soon as they did. But then to add silicon, which adds all these other stresses to the battery cell, are they going to be able to do that with like that two-binder structure, or are they going to need something else in the anode as well to help hold things together? So they might end up doing that in the future.
Right.
What is that name of the company? I forget what it was called.
The one I saw was Oxala.
Okay, I haven't heard of them.
I
All right.
believe it's like they just have oxygen, carbon, whatever the next few elements are in the periodic table as their names.
Okay. Now, I may have heard of that before. There are so many startups. There's hundreds of them. I was thinking it might be, there's one other company that was kind of like an offshoot of Maxwell, one of the original researchers of the dry battery electrode. She started her own company doing dry battery electrode. And so even though Tesla is the furthest along in commercialization, it's important for people to know that there are other companies out there working on it.
Right.
So,
It's not a monolithic technology.
yeah. So the question is how far ahead Tesla is in commercialization. I don't see anybody else picking up that technology and using it for at least a few years.
You know, one of the popular phrases is mass production is hard.
Yeah.
And because they are able to do that, that's what puts them ahead of everybody else.
And one thing that Gene Berdichevsky, he's like Sila Nano, he started his own battery company as well. He used to work at Tesla, but he's like first to scale wins. So even if you might have a technology that's slightly inferior, if you can get it to scale first and become profitable, well, you're the one that's going to survive. And you can take that money, roll it back into the product and improve it. Even if you start with an slightly inferior product, you can.
Well, speaking of that, there was the recent sodium ion vehicle in China. First to market, not the best out there, but it is the first.
And that's something I wanted to talk about with you, because I want to try to get you twist your arm to get your hands on some of those sodium ion batteries by maybe importing a vehicle, something like that. I don't know because in the past you've done fundraisers to gather money for like the Plaid Model S, the Tesla Semi, things like that. Whereas this isn't like $100,000 vehicle. Mm-hmm. It'll be maybe a $10,000 vehicle, but the shipping is going to be expensive. And it's going to be, I know how much trouble you guys went through shipping those 4680 battery cells around the world. Oh my. Yeah, it's like basically saying, oh, I want to ship bombs to every country in the world. So,
that's essentially what it worked out to, yes.
Yeah. So I know other people who had ordered cells and that they're patiently waiting for their cells, but they understood that it was quite a process to get those shipped around the world. But yeah, so importing one of those vehicles might be difficult, but for me, that sodium ion battery chemistry and that sodium ion battery, for me, is as important to the transition to sustainable energy as the 4680 battery cell.
Absolutely, yeah.
So,
no, I agree, because that not only, sodium ion on its own is essential, I believe, for storage technology. It's just a little bit heavier. It's a little bit less energy dense, but getting that into the massive market of energy storage and distribution would free up lithium ion for other ventures such as the vehicles.
Yeah, the sodium ion is better for energy storage than like an LFP battery cell, because it should be able to scale more easily. It's going to be a little bit less energy dense, which, that matters less for energy storage. It still matters for energy storage, but it's going to be, ultimately, it's probably going to be about, 30 to 40% cheaper than lithium ion batteries at scale.
That's what I've seen.
And then it's also going to be high cycle life. And what matters most for energy storage is cost per kilowatt hour per cycle. One of the main reasons I want to see a teardown of one of these sodium ion battery cells is because they do have drawbacks. Mm-hmm. People think, sodium ion, problem solved. But it's like, well, the extent that technology is adopted depends on how many of the problems that they've solved. Like, for instance, because it has such a wide voltage range, right, you might see a significant power drop between a fully charged and a fully discharged battery cell. Whereas LFP, it's the voltage is flat.
Which is its own problem.
Yeah. So all these things, such an excellent point. I love it, because people think it's best to either have a flat voltage profile or a slanted voltage profile. It's like, no, each of them poses different problems.
Right.
Because even though you might get more steady power output throughout the discharge cycle, it's also more difficult to read the state of charge to know how much battery cell that you've used. So for sodium ion, it has a very steep voltage profile. So it might lose a lot of power as it's discharged. Could that be an issue? Maybe, maybe not. It depends on, not just the voltage, but the current that you can pull out of it.
So yeah, it's almost as steep as like a lead acid battery, but it also has a different construction. So you have hard carbon anode. You have, I believe, CATL is using the Prussian white cathode. What's the electrolyte going to be? What's the separator going to be like? You're going to have a different porosity, different size pores in it. It's going to be different in a lot of ways, and that changes the economy behind the cells.
Exactly. It's like every new battery cell is an alien technology. People think they're like, we'll just swap out sodium for lithium. It's like, no, you pull out that lithium and you swap it for sodium. everything else in the battery cell changes. You don't need to use copper on the anode, for instance, anymore. Right. But to your point, that's interesting of itself for people who are battery geeks. But from the perspective of Tesla and the industry, how does that affect scaling up these cells? Because, all right, so we've removed the bottleneck for lithium because it's, there's much more sodium available out there than there is for lithium for batteries. So that eliminates that bottleneck. But what does the new bottleneck become? Does it become the hard carbon anode? Does it become this or that?
So yes. So hard carbon is an interesting one. I've been looking into that one pretty deeply because of the potential of a graphite shortage. Right now, the entire the global economy is built around Chinese supply. Not even just supply, but refinement. So it's controlling the doors and corners, access and pivoting. So conversion. China controls 90% of the graphite production and 100% of the refinement.
Yeah, that opens a few doors in my mind. So one more reason to get our hands on those cells and find out like what material, because I think by looking at it, you might get some indication of what raw material that they use to produce that. So it gives you an idea of maybe what's going on with the supply chain. And then there's one more point on sodium-ion batteries is that their charge-discharge efficiency supposedly isn't as good. Like, lithium-ion battery, 98%, you might lose like 2% to heat and other effects, whereas typically people expect a sodium-ion battery to only be about, 85% efficient, with newer versions claiming in the low 90s. But still, that's a 5% extra energy loss that you're incurring with like a sodium-ion battery.
Right. A lot of that's in your first charge, irreversible loss.
Okay.
That's a product of the anode. So the hard carbon does not work like graphite. It's not intercalation, but because it's amorphous, it's more of an adsorption to surfaces. So it is easier to bind to, but harder to separate stuff that gets deeper into it.
I got you. Yeah, because like when I've seen images of like CATL and things like that, there's just like these little pockets, whereas graphite is just like perfectly ordered. This is just like a jumble, like somebody threw a whole bunch of sticks on the ground, except it's like, sheets of paper. And then the lithium just has to find an open space in there.
But graphite will not work with sodium ion. Yeah. It's just too big. Mm-hmm. And it's weird because it gets down to chemistry issues. It gets down to physics issues. Like this is literally just too big to fit into the space.
Yeah, as one of the best descriptions I've heard, it's like we're getting so deep into the geeky stuff here. So probably pull back out after this, but it's a multi-physics, multi-scale system. People are used to dealing with things on like one type of physics on one level of scale, but batteries are just so complicated. And you're dealing with electrochemistry, mechanical chemistry, and you're dealing with it from the size of an atom all the way up to a battery pack, which you're looking at like a million-fold scale there, something like that.
Right. And you see that even like with sulfur batteries because of the chemistry changes. Like sulfur will do a S8 ring, but the S7 ring and the S6 and the S5 causes so many different changes in the way the properties, the electrical properties, as it reacts or as it interacts with the electrolyte and the distribution of the positive negative current, that it affects the predictability and reliability of the cell.
Yeah. What he said. I haven't looked that much into sulfur, but I know that's like every time I look into a chemistry, I realize how ignorant I am anytime I look into new chemistry because of all the new things that happen.
Well, take like magnesium as a hypothetical. Mm-hmm. It's a divalent ion. So you have Mg+2 and you have Mg+1, and they're both going to react differently at different rates.
Yeah, I'm trying to understand, like CATL, their new battery chemistry, maybe we can talk about that. Their MP3 chemistry or M3P chemistry. Yeah, so basically it's LFP, and then what they've done is they've added some manganese. The manganese increases the voltage, but it also makes it more unstable. So they've doped it with like aluminum and a few other things. But yeah, one thing that happens with manganese is it has all these different oxidation states, and each one of them causes different issues within the battery cell. So that's why you have to add the other chemistries to balance that out.
Manganese, I think, has the most oxidation states of any transition metal.
I don't know, but there's at least 4 that I was looking at.
Yeah, so those oxidation states, I said ionization, but it's definitely oxidation. That plays a complete chaos situation when it comes to the chemistry and predicting and controlling.
Yeah, because I don't know if I want to get this deep into it, but you get into things like Jahn-Teller effects, where the shape of the electron clouds within those atoms, it gets lopsided, and then that actually changes the whole crystal structure because one of the electrons is kind of swung around. It's like, what? Oh my God.
And your atomic radius changes too, so it might not fit as efficiently in the 3 state as opposed to the 7 state. So. Yes, it becomes a nightmare in that situation. That's why everyone likes these pure systems where lithium, it's one thing and it's got one electron floating around, and that's easy. So, but when it gets to like the hybrid pack, like Cattle wants to use with a sodium and lithium ion, so they're balancing that kind of stuff, but they're doing that with like the BMS system.
So, do you have? Okay, so there's a couple different directions we could take this. One is the hybrid pack that CATL is working on, so hybrid sodium and lithium, and then the other is the LFMP or the M3P battery. With that hybrid battery pack, do you think that's a gimmick, the way that like battery pack swapping and things like that? Because to me, it feels like a gimmick. Why not just put all the same cells in the same battery pack and then specify, use your LFP battery cells for this type of vehicle and use your sodium battery cells for another type of vehicle?
Yeah, I probably defer to you more for this. I'm not as familiar with the hybrid chemistry, but from my understanding, it certainly seems like a specific chemistry for a specific vehicle application seems like the most straightforward way to go. But I'd be open to hearing your thoughts dumbed down for me. Please.
I think that them just trying to get a marketable vehicle. If you just have sodium ion, you're gonna have a 70-mile vehicle. You toss some lithium ion in there, you can go up to 125, 150, and that makes it somewhat marketable.
I hadn't thought about it from that angle, but that makes sense as well. I thought it was just like, it seems like in China, they do a lot of things. It's like, this looks cool. Let's do it. But that actually has more of a pragmatic, that's more of a pragmatic view.
Yeah. I wonder if the additional complexity that would be driven by having a hybrid chemistry like that would be worth what additional marketability you would gain just being able to advertise a little more range like that.
That's an area I'm not too familiar with, but I think so.
Because just from my, and I have seen your video on the sodium ion batteries. I love watching your stuff. It's incredibly helpful to me just to be able to kind of keep up with stuff, but also there aren't a whole lot of places that go into such a high level of detail. I don't have a chemistry degree like Antonio, so, kind of having things laid out in a, technical but understandable way, it's very helpful. But, applications for a sodium ion battery for a vehicle, if it doesn't necessarily need to be super long range, if it's just like a commuter car. So my mom has it's a 2012 or a 2013 electric Ford Focus, and she's had this thing basically since it came out, or maybe since like 2015. It's advertised, I think they listed as like a 76-mile range. It's a 23 kilowatt hour battery pack. And this thing, I think at this point in its life cycle, you're lucky to get 53 miles out of a full charge, but she takes it literally just back and forth to work. Her office has level 2 charging there, so she just can leave it plugged in during the day. So for something like that, when it's not being used more for like driving a few miles to work, maybe going to the grocery store, you don't need a whole lot of range. I don't really see the need to be able to advertise every vehicle as having, 300, 400, 500 miles of range if all you need is something that's less costly, just more kind of commuter daily driving kind of thing. But at least that's how I see it, just knowing somebody who uses an EV for just very basic, stuff, not necessarily road trips or longer commutes like that.
That makes perfect sense. Like, it is definitely a user case.
Mm. Yeah, and I think it's nice to have that option open if somebody doesn't want to drop, however much we paid for the Model S Plaid here, or I mean, you know, the Rivian is, you know, so they're all fairly expensive. So having an option like the CATL vehicle with the sodium ion cells, having that be more affordable for people who want an EV but maybe can't justify the cost of something that's, you know, a rocket on wheels. You know, I think it should be accessible for people to get into that, and I don't think they all need to necessarily be a Model S Plaid. I think, you know, something a little less performance oriented is totally acceptable, and I'd like to see more of that on the market.
Yeah, I really don't want my grandmother driving around in a 0 to 60 in 3 seconds car. So, but then again, she might enjoy it. So it's not up for me, not up to me to say that. Yes. So your other item was LMFP, right?
Yeah.
So manganese, that's an interesting one because it definitely adds effects to the cells. The cathode, it's like it gives you that voltage. So that's one good thing. It's temperature. It's more likely. It's more energetic. So yes, it creates a temperature difference. But it basically just improves the overall LFP performance. It kind of gets rid of that flat curve a little bit.
For me, the feeling I get with this M3P chemistry is that, like, there's enough differentiation between the LFP chemistries and the nickel chemistries where you have two distinct products. With the M3P chemistry, you're going to be adding cost because the M3P chemistry will cost a little bit more. At least my understanding is it's going to cost more on a kilowatt hour basis. And then because you're packing more cells in the pack, you can fit more cells in the pack. It's going to, you know, the pack itself, it's going to be, you know, probably end up being 10 to 15% more expensive for that. So what it's going to do is it's going to create this space between an LFP chemistry and a nickel-based chemistry. I don't know if we need that. To me, it seems like, you know, like we're fine with the LFP and the nickel-based chemistry. One thing it might do, maybe you can just, if you really want to simplify your product line, split the difference, eliminate the LFP, eliminate the nickel chemistry, and then have something that's like, you know, somewhere in between LFP and nickel. So I guess what I'm saying is I don't know where it fits in the market. It seems exciting and interesting, but what's the use case?
That's a very good point because if you think of it from a lean design perspective, the less variability you have, the more efficient your cost centers are. Do you really need it? I think you can get away with the LFP with the mass market vehicles and the high nickel with the specialty cases. Do you need it? I don't think you really need it.
Yeah, especially if you're already doing an LFP or a nickel-based chemistry. I don't, you know, if you're only doing in between, then yeah, maybe. But no, I think if you have the sort of the low end and the high end of where that would sit, I don't see a need to invest in that as well.
Well, not to mention that, but you also, like, as the technology improves, that gap between what LMFP was or LM3FP accomplished and what LFP can accomplish, it'll shrink. So you can get rid of that just by letting the technology mature.
Good point. That's the conclusion I came to. It's like we know that CATL has better pack technology now that eventually come to like a Tesla Model 3, and that's going to give you maybe 10 to 15% more battery cells in the pack. So no need to change the chemistry, just change the pack and you're already getting that kind of boost. But the thing is, you pack more battery cells into a battery pack, and that battery pack is going to cost more. So will Tesla even want to do that? Because people always forget that, yeah, 10 to 15% more energy density, but you put those cells in the pack, it's not free. Right. You're going to be paying for those.
Yes, you will.
We've been running numbers just for our own internal purposes, but like what we found is like Tesla leads the way in dollars per kilowatt hour or kilowatt hours per dollar. The amount of cells they put in and the range that they get out of it is more efficient on their level than anyone else. So
I've never considered it that from that, because I know they get things cheap, but then they also have to, there's an exponent there where not only you're getting them cheap, but your entire vehicle level efficiency is better as well. So you're not just getting, say 10% cheaper battery cells, you're getting 20% more range out of each of those battery cells. So yeah, all these all this stuff that Tesla does compounds on itself, which is one of the reasons why it's so fascinating. They're not a one-trick pony. They're stacking all these innovations.
And which is going to make it more fun when it comes to the Cybertruck, because they're doing the exoskeleton, they're doing the castings, they're doing the high nickel chemistries, hopefully. The version 2 or 3 of the 4680 cell with that different chemistry. So it'll be interesting. From a cost side, I have no idea. Like cold rolled steel, 30X, whatever cold rolled. What do you see on that side, Julian?
In terms of the battery cells themselves?
Or just the amount of weight you can remove from the vehicle by changing the composition and structure of the car.
So for the body structure side, that's not as much my forte, but certainly like when we, I mean, just looking at the Giga castings as a prime example, just one that I, know off the top of my head and we've looked at. It's a lot of that stuff that, I think we found out that the Giga castings really were almost a weight neutral change. It was purely just for a process save, ease of assembly. So
that's true.
Something like that. And that's actually a very critical point that I think a lot of people, when they can be critical of some things that Tesla's looking at doing, like the Giga castings in terms of repairability or what have you. It's not necessarily that they're always looking at driving down the piece cost. They're also looking at assembly cost. So, you have roughly the same amount of material in terms of weight between a Giga casting and what was used in the vehicle before, but they've got one piece, not, I forget how many they were able to consolidate with that even. But so they're looking at it more in terms of how can we build it quicker and how can we have the process end of it be less costly, as opposed to let's just make the component itself cheaper. So yeah, in terms of the vehicle side of things, it may not necessarily be a cost save, but the battery itself, so like the 4680 pack, if we talk about like the material and structure there's obviously a lot less inside that than we would see in almost every other pack we've done with the internal extruded lateral reinforcements, things like that.
Right, assembly was so much easier for that.
Yeah, because you can effectively, instead of having a complex series of extrusions and stampings all welded and bolted together, you can, the 4680 pack, I think was like a 4 millimeter thick stamping for the tub itself, and then, the cells were just dropped right in. So there are significant weight and cost savings, taking that kind of material out of the pack.
Did you get a chance to go through the master plan part 3?
I was able to go through, yes, I caught a couple recaps of Investor Day, went through some of the notes that you had compiled. I didn't get a chance to go into it in as much detail as I was hoping to, but the broad strokes, yes, I am familiar with.
What did you think of the the assembly change where they assemble the vehicle in a completely different way, where like they don't coat it?
Oh, I think that's kind of brilliant, actually. I don't see anything wrong with, and I think they did in their presentation made the point of the existing assembly line has been around since Henry Ford invented it 100 years ago. And after 100 years, how much can you really improve on something when it's used by however many, basically every OEM on the planet at this point, maybe except Tesla. So I don't think that there is anything wrong with finding some other ways to look at it. And I think in terms of building up sub-assemblies like that and just doing one, only really assemble the vehicle once. Because when you think about it, assemble the doors, paint them, take them off, then do all the building up. It's getting those kinds of redundancies out, which I know Tesla looks at in terms of their process and just eliminating that at every step that they can. I think that that's a great idea. And I was very intrigued by the way that they were explaining all of that. And in terms of process efficiency and how much less costly that's going to be, and factory floor space you get to save too. I think it's a great idea.
And that also applies to like the new winding technology. So when they went to the hairpin design as opposed to the traditional winding, so even that will improve the process.
Yeah, being more automated because like we discussed earlier, the hairpins versus the windings. There's more automation, and I'm glad to see that. I'm surprised it did take them this long, but like you said earlier as well, it's you're in a car going 80 miles an hour, you can't change the tire, so.
And you are looking into some of that as well for something coming up.
Yeah, I have the video is complete. I just need to do like a final pass on it. One of the things that you mentioned before the video that you wanted to understand is like what parts of the video that I do as well. It's everything. It's a one-man show.
Okay.
So it's and it's one way that I could, because like I don't put out many videos. I put out like one every 2 weeks. And there's a lot of people want me to increase the pace, and it's like, well, I've tried to increase the pace. Like, do you realize how much like effort goes into these videos, and it's just me working on it? Like, well, why don't you outsource some of that? Sorry, if I want to keep the level of quality up, I can't. And it's not just me being obsessive compulsive or controlling. Maybe I am obsessive compulsive, but in terms of, I've tried to bring other people into it before, but what happens is, as I'm assembling the video, say I do the script, I do a rough draft, I go through that rough draft and, just clear out the errors. But then what happens is I start pulling together all the images. And as I'm pulling together images, I'm researching at the same time because I'm looking for images that match what's on the script. And I realize, oh, this is totally wrong. I find an image that conflicts with what I did. It's like, I have to cut that out or rewrite it, etc. So as I'm working through and finding all the images, I realize that I've made errors. So it's a quality check when I go through and add the images. And then when I do the voiceover, I realize, this really isn't flowing now that, this doesn't make sense now that I'm hearing the words come out of my mouth. So then I have to do another editing pass there. So it's always, I'm constantly redoing parts of the videos. It's not just like I sit down, write it, pound it out. It's like, it takes me about 10 days at least to make a video.
Okay.
And this isn't including all the research.
Right.
Which that's another side of it. I'm trying not to take this too many directions at once, but basically, and then, as I said, Tesla will give us updates while I'm making the video. So that throws a wrench in my tires as well. So anyhow, it's like, I have to do this all myself because it can't go through more than one mind. It's kind of like the same reason why Tesla overloads their engineers and gives them like, we're not going to divide this between 5 people. We're going to run it through one brain because that's the best way to do it. Anytime that you add other brains to it, what you're doing is that there's it's like contact resistance. There's something lost every time you have to transfer the information to somebody else. So I wouldn't be able to have the level of quality I do if I divided it amongst people. Now, in terms of the research, every video that I do, I know a level deeper than what I've put into that video. I want to make sure if somebody asks me a question in the comments that not only do I understand what's in the video, I understand why the things in the video are the way they are and how they connect with other industries, other technologies, etc. So I thought when I first started the channel that I would do one video and then I would be out of ideas. But what I found is that there's this focus, this spotlight of knowledge that you have. And there's like a periphery, like an edge to that. There's all the things that touch that little piece of knowledge. In order to do this little spotlight, it has all these connections around it. So every time you do a video, it gives you ideas for 5 more videos. So I have hundreds of one paragraph notes that I've made to myself about things that I need to discuss. So yeah, it's this spider web of information that happens when I'm researching the videos, and it's never ending because there's new information coming out each day, and I have to integrate that into all these spheres of knowledge that I have and make sure that I'm not tripping over myself.
Right. So we get that on our end as well. You have to stay up to date, process changes, new technologies. Yeah. And if you don't, you become stagnant. Stagnation is dangerous. If you become comfortable, you become replaceable. And
you have to be psychotically obsessed to a certain point. Because this isn't it's not just I'm working on these things for the videos for 10 hours a day, or 6 to 8 hours a day, 7 days a week. But then on top of that, in my free time, I'm on Twitter talking to people about things, and they're like just bouncing ideas around. People are asking. It's just constantly. While they were out partying, he studied the blade. So I do not have a life. So this is everything.
There's just so much information to absorb.
Mm-hmm.
It's, just us trying to keep up with things here. It's really overwhelming. So, I mean, kudos to you for how it's a lot to keep track of.
Yeah. I don't even know how we got onto this topic, but one thing I was thinking about on the drive up here, because it's something that I was discussing with Sandy on, I think it's Farzad's channel before we started the interview one day. And it was, how do you deal with poor performance? Like, because sometimes I've been at places before that you have somebody who's basically dragging the team down, et cetera. And usually that was in a bureaucracy. You can't get rid of the person and you're kind of stuck with them. How do you keep your level of performance high here? Because you have a high performance organization. What are the rules around that? Do you go tell Dad, Sandy, or who makes the decision?
I don't know. I think because we're a relatively small company. We're maybe hovering just over 90 people total, and everybody has kind of their own specialty. So Antonio and he's more battery chemistry and battery oriented. My background's in mechanical engineering, materials. So I've kind of fallen into the battery stuff as I've been here, but then it's also like integration to the vehicle and some of the automotive side. But everybody kind of has their niche. We have an electrical team that's comprised of a couple individuals who are all very, very good at what they do, different specialties, high voltage, power electronics, circuit boards, wire harnesses, things like that. And so I think it's honestly, we all just kind of check ourselves, and it's because there's so few of us and almost every project we get in the door, everybody is involved in some capacity. We all want to kind of keep up and do as much as we see everybody else doing. I don't know if you have a different perspective on that, but just as far as I feel.
No, that's definitely true. And a lot of it is our line of business kind of encourages the learning process, because we're bringing in new vehicles all the time. We're seeing what's changing. And we have to research to stay up with that. So we had the Lucid and the Hummer in, so those are completely different materials. The Rivian's using a different chemistry in their cells. Yeah. So we have to understand how these work. We're compiling a report because, like you said, a lot of the information out there is just not right. Mm-hmm. So we're generating our own material. We're doing a battery report that is just on electrical performance, physical characteristics of cells, and we're trying to improve the knowledge base that's out there. There's other people that are doing it, and we're trying to partner with them more so that we can throw information back and forth at each other. But our goal is learning as much as we can, improving the knowledge that is out there, and then we learn in the process as well.
Yeah, there's a certain amount of entropy to knowledge and information. And what you guys do is so helpful, because there is like, for instance, I love the Tesla community, but there is sometimes, boom, a new piece of information hits, and it's just like all this speculation that's sometimes there's not even enough information there to speculate. This is PG, isn't it? But there's a word I have for it. But there's somebody has an idea, and then people repeat it, and nobody questions it, and it just gets passed along, and it grows. It's like this game of telephone. So when you have people like yourselves putting a stake in the ground, clearing up information, providing accurate information, it's so helpful. I often reference or look at your videos on things that you've done, or even use your B-roll in my videos. It's so helpful. Yeah.
Well, I think we're getting nearing our time. So from Antonio and I, everybody here at Munro, thank you so much for being on here. To anybody listening, if you have not somehow happened upon Jordan's channel, please go check out The Limiting Factor on YouTube, an incredibly helpful resource if you're more technically minded or if you're just interested in batteries and how they work. And thank you so much for listening.